Hi everyone, welcome to Java Techie. In today's fast-paced world of API development, performance is a key factor that can make or break user experience, and also high latency API can frustrate users and even lead to lost revenue, isn't it? So in this tutorial, I will discuss a practical approach to improving API performance using multithreading concept, and I will also walk through a hands-on example using Spring Boot. Okay, all right. So without any further delay, let's get started. So before we directly jump into the logic, first let's understand the use case. Imagine you are building a new microservice or API where it needs to fetch the data from different sources such as database or external service, and at the end it will consolidate the result and return that result as a final response. Now think what happens when any of the service is slow or there is a network latency, then definitely it will downgrade the performance of your application, right? And since this is a synchronous call, it's common that your main thread will be blocked until each response is returned. So here all the three microservice call will run in a single thread. So it does not make any sense to keep a multiple task in a single thread, right? This design is not acceptable at all, isn't it? Now, how can we improve the performance? Well, this is where we can play with multithreading and make the call asynchronous and non-blocking. So here what we can do, each step, fetching the product, fetching the price and fetching the inventory will execute concurrently, which will be executed in a separate thread. So fetch product will be executed in thread 1, fetch price will execute in thread 2. Similarly, fetch inventory will execute in thread 3. So each and every task will run in a different thread, which will help to reduce the overall waiting time, isn't it? This approach sounds good. So let's do one thing. Rather than go with this theory, let's design this fetch scenario using both sync and async approach. Then we can easily differentiate the performance. Okay, we can easily differentiate the waiting time in sync and async. So let's go to our IntelliJ idea. So to save our time, already I created the skeleton by just defining the entity class, repository class and service class. You can see here three different service: product service, price service and inventory service. So if you understand the flow, from the new service, we do three external call to three different microservice, right? So to make the example simple, instead of creating three different microservice, I have defined the three different service to just simulate the microservice call. Okay. So my intention here to just give you the context of API performance using synchronous and asynchronous, using multi-threading in real-time implementation. Okay. But in fact, you can also define three different microservice and keep the same logic over there. Fine. Now let's do one thing. Before I go ahead and start writing the code, first let me show you the database structure. Okay, the schema structure. Let's check in the DB. So I have these four entity: product, category, inventory and price. So if you'll check in the product, we have the product ID, name, description and status. And also if you observe, product is mapped to this category table. Okay, in product table, the category ID is the foreign key. Now if you check in the category table, it's just ID, name, type and status. Now if you check in the inventory, you can find out, okay, inventory ID is this is what the product ID, available quantity, reserved quantity and status. Okay, and there is also, you can see the mapping of product ID in this inventory table. Similarly, if you check the price, you can find the product mapping to this price, saying that okay, this product ID having this price, okay, and valid from valid to. Like I have just manually inserted the record to just demonstrate this sync and async, or to just fetch the record from the DB. Okay, that is what the simple thing we have done here. So now let's start implementing the code. First we'll write the synchronous logic so that all the call will be executed in a single thread. Then we'll observe the performance, then we'll implement the async, and then we can compare the performance. Okay, so what I can do, since I have created the service, better let me walk you through the classes what I have defined here. So these are the entity what we just observe the table, product table having many to one relation to the category, and then other field. Similarly, if we'll check, we have the category having ID, name, type and status, inventory having product ID as a foreign key mapping and all the field what we just observed, then price, ID, product ID, price. Okay, these are the entity, and I have the repo. It's just a Spring Data JPA plain repository, extend it from JPA repository for each entity. You can see here, right? Next, let's go to the service. So if you can observe, I have defined three different service. Let's go to the product service. We have the method find the product by ID. Then again in the price service, get the price by product ID, and in inventory service, get the inventory details by product ID, because this product ID is mapped to price entity and inventory entity. Correct? So I have defined three different service with the simple get method, and if you check the implementation class, nothing is there. Just doing the simple DB call to simulate the performance related stuff. I just forcefully added some delay 2 seconds. For each call I have just added 2-second delay. Now if you check the same in price service also, we have the same logic. Just call the price repository, find by product ID, get the price by product ID, and just added the 2-second delay. Same I have done here in the inventory service as well. Can you see here? Plain repository call and then delay for 2 seconds. The delay I added forcefully to just show the time difference in sync and async call. Okay. Now what we will do, since we have created the service class, let me define a facade package so that which will be act as a what I can say, which can orchestrate the business logic from the service layer. Okay. So we can have a separate facade to just demonstrate sync and async. So I will just create another package. Now just let me create a class saying that product sync. Now in this class, what we want to do, let me keep a note. So we want to fetch the product, then we want to fetch the price, inventory. Okay, after fetching all these result from three different service, consider these three are the microservice call, then you want to prepare or build the final result or consolidate the result. Okay, so that is what we want to do. So I have also created a DTO who will capture all the consolidated result from three different service call. Okay, ID, category name, what is the price, what is the status, what is the available quantity in inventory. So all the three different service call response will be mapped to this particular DTO. That's pretty simple. Now I'll write a method public who will return the product details DTO. Okay, and just define the method name. Now just call each and every logic or just execute each and every logic. So to fetch the product, we need product service, right? So let's inject all the three service, product service, price service and inventory service. So just define private just use auto add, or even you can define the constructor. Since we injected the services, let's use them directly. To fetch the product, I can use product service dot find by ID, give the product ID, it will return with the product object. Just get the result. Now what is the next? Fetch the price. Now just fetch the price. So you can use the price service, get price by product ID, give the product ID. Similarly, what is the next? Fetch the inventory. So here just map the result, which is nothing price. Then fetch the inventory, which is nothing inventory service dot get inventory by product ID, give the product ID. It's just a simple DB call, guys, nothing else. Okay, now you have the result product, price and inventory. Now let's create the new product details DTO object to map the value from each and every response. Okay, so it's very simple step. Return new product details DTO, give the long id is nothing, your product id. Then what is the category name? You will get the category name from product dot get category dot get name. Okay, then what is the name of product? You can get it from product dot get name. Then description, you can again get it from product dot get description. Now this available quantity you can find it from inventory, right? Inventory dot get available quantity. Similarly, price you can find from price object, price dot get price, and status I guess you will get it from inventory, I guess. Okay, let's see. Inventory dot get status. Yeah, all good, right? So let me format it little bit. So this is the combined result from all the services, right? This is what we want to do. Just remove this. So you can add better, let's add some log statement as well. Just add here, add some statement. Just change it to sync, right? Fine. Now we have this simple logic to get the product details. Now what happened, this method will execute in a single thread, and in a single thread it will do this call. Consider this as a microservice call. Again I am repeating this use case, I make it simple to just explain the actual concept what we are looking for. So this will fetch the product details. If this fetching the product details is taking time, then this won't execute, this will block till the thread is free, right? Then next, once that is done fetching the product, then it will fetch the price. Again if there is something going wrong or there is a delay, this logic will not execute, because all these three will be executed in a single thread. Okay, that is what the synchronous call. Now let's write the logic for async, then we'll check the waiting time, or we'll just compare the difference in sync and async call. Okay, so I'll just create another class. We'll just change the name to async. Here also we need these services, right? Just inject them. Now what we want to do here, each DB call or each service call I want to run in a separate thread. Okay, fetch the product, fetch the price, fetch the inventory, all three will be run in three different threads. So what I can use, recently if you check my YouTube channel, recently I uploaded couple of video on completable feature, right? So after Java 8 onwards, this completable feature is widely used in industry to implement the multi-threading concept. Okay, so again we'll use the same completable feature, which is the simplest way to perform the concurrent operation. Okay, so what I can do, first let me define the method. I'll define the same method. Now all the three tasks I want to run in a different thread. So first task for me to fetch the product details, so I'll just define a method public completable feature. Okay, what it will return me, it will return me the product object. So I'll define the method get product by id, just pass the product id. Then you know how to create the completable feature instance or how to run the task in a thread. So it's simple, return completable feature dot supply async. This will take the argument as a supplier, so you can call the product service dot find by id, give the product id. Okay, similarly I will create three different thread for three different tasks. We have done for product, now let's do for price and what is the last, inventory. So just change it, price, change the method name, get price by product id, right? Then get inventory by product id. Okay, so just change here, this will be your price service. What is the method name, get price by product id. Same here, right? What is for this, inventory, right? Inventory. Then just change here the method called inventory service dot get inventory by product id. Just pass the product id. Let's format it. So again you can just add a note. I don't want to make it more ugly, so you can add a just a note to understand okay what each thread is doing here. Fine. So once you get the completable feature, then what you can do inside your method, the get product details method, you can fetch them asynchronously, right? So what you can do, get product by id, give the product id, call all the three method. Okay, all will be executed in a different thread. Just define the variable. Just call this one, then call the inventory one, pass the product id, just define the variable. Okay, so all good. This is the logic. Let me add a node, because see, remembering the syntax in multi-threading is not simple, right? So even though we learn completable feature, but it's difficult to remember their method name. So better to just keep a node for your understanding. So just add it, fetch all asynchronously. Okay, then what next? Once you get the feature, then you need to wait for all feature to complete, then only you can combine the result, right? So for that what you can do, you can use completable feature dot all of feature. What all of feature? This product feature, then price feature, then inventory feature. Once all the feature is executed successfully, then combine the result. So this is what we are wait for all features to complete. Once they complete, then combine the result. Okay, so it's very simple. Just call the join method. Okay, so product feature dot join, it will give you the product object. So this is product, right? So it will give you the product object. Now just do the join for all the feature. Now do for price feature dot join. Now once you get the result, just do one thing, build the combined result or consolidate result and return. So I can use the same constructor, right? I can copy this. Okay, all good. So what we have done here, we have created three different completable feature to execute the task concurrently: get product by id, get price by product id, get inventory by product id, right? By product id. Okay, let it be, I don't want to. Okay, let's change it. Fine. Then what we are doing here, get in the get product details method, we fetch all the feature asynchronously, then we wait for all the feature to complete their task, then we just combine the result. This is a simple logic, guys. Okay, fine. So we have two class now, first class product sync and async. Now let's quickly create a controller so that we can invoke these two methods. Okay, so what I'll do, I'll just create another package, then just define a controller class quickly. New Java class product controller. Just define the root URL mapping. So you can define something, anything you can define. Let's define a good name, API slash b1 slash products. If you want, you can add the log SL4G. It's not required for this demo, but you can add a log statement to check the flow. Okay, so let me define two endpoint, one for sync, one for async. So first let's inject the product sync facade and async facade. So for that what I can do, I'll just do private, just do the auto add. So just define the endpoints. Okay, let me add the import statement. All good, right? I've created one for sync, one for async, and in sync we are just using the product sync facade, which will execute in a single thread, and this async call will be execute this facade, which will run in a completable future 3 different thread. Okay, so we'll run this endpoint and we'll see the response time. Okay, that is what, if you see the response time changes in sync and async, that is what we are trying to convince in this tutorial. So what we can do, let's start the app. So it started, yeah, on port 9191. Now let's go to the postman, and what is the endpoint? 9191. Then API v1 products. What is there for sync? Let's go to the controller class. First we'll check the sync ID, give the product ID. So if you'll check in the table, what is the product ID we have? 1 2 3 4. Let's take any product ID, that's fine. Just go to the postman, product ID will be 2, and this will be sync call. Okay, so just send the request. So you can see the result here, right? The result combine of all the 3 different service call, or in our case 3 different DV call, and this is the consolidated result. But the main thing what we are trying to focus here, the time. Okay, because all the 3 DV call happened with a single thread, so it took 6.75 seconds to execute get product details method. Okay, and this is the synchronous call what we have triggered. Fine. Now just keep an eye on this number, 6.75 seconds. Now what I will do, I will duplicate this. Okay, this will be 6.75. Now let's trigger the async call. Just change the URL, that's it. Fine, let's see what is the number we are getting here. Can you see here? We got the result, but what is the time difference here? 2.11 seconds. Since we are playing with the less data, just 3 objects and having displaying these many 8 or 7 JSON field, you won't find much difference in the time. Try playing with thousands of key and value of JSON, then you will find the huge difference. But now also this is visible, right? The number 6.75 is in synchronous call and 2.11 second in asynchronous call. Okay, so it's always recommended whenever you are implementing the RAID operation with multiple tasks, don't keep them in a single thread. Try playing with the multi-threading concept. Since you know this completable feature, each and every step what we have done here, isn't it? So it's just a simple step. Okay, so what we have done here, you can implement similar kind of multi-threading implementation based on your use case. Okay, so just give a try with the large data set to find out more time difference or routing time difference with sync and async. Okay, so just give a try and do let me know in a comment section if you have any doubts. That's all about this particular video, guys. Thanks for watching this video. Meet you soon with a new concept.